All right, folks, so I don't want to as far as projects go, I have to get to the right class, don't I? Here we are on 127. All right, so the lecture, I just went through the format string projects. That's what I did. So you've already seen essentially a demonstration of that. So the only other thing I thought I'd show you is this race condition, which is an extra credit project, but it's a cute one, and this keeps coming up. Race conditions are like this cartoon where you have two processes that share something in common, like a temp file, and one of them changes it without the other process knowing it. So there is a brief period of vulnerability. And so you can do this on any Linux machine, like the same one I've been using, a Debian machine. And what you do here is you create a new user with low privileges called noob. And then there's a program here. And what this program does, it's carefully written to duplicate a race condition. So what it does is it checks at this time and it determines something about a file. So this is the time of check, then it wastes some time, and here's the time of use. Now it tries to open the file, read only. And the point is, the way this is done, it checked here, it got a pointer to the file, and then later on it tried to print it. So I'm not sure I can see quite clearly from this thing, but the point is, okay, here it's going to try to read from the file, and these complicated commands cause it to read from the file with your permissions. Anyway, I'm going to just show you how it runs in practice rather than worry about the format there. If you go here to you can change to noob with suid noob, su noob. Yeah, and then noob is the password. Okay, so now I can go home. All right, and in here I have a couple of files. So let me just make my font bigger. All right, so if I do ls-l, what's going on here? Here is this race file compiled, which you do by going through the commands there, and that creates a special permission here. So this program is owned by root, and it runs as root. And what it does is it prints the contents of a file like cat. But it prints them with your permissions. But it does it in two stages. It checks the permissions, and then it prints the file later with a time delay in between. So I have two files here. This one is public, created by noob and owned by noob, and this one is secret, created by root, and only root is allowed to read it, nobody else. So if I use cat and I look in public, I can see what's in there, but if I look in secret, I'm not allowed to go in there because only root can go in there, and I'm not a root user. If I use race, race does the same thing as cat. If I go into public, I got to use /race. Okay, it prints the public information, and if I go into the secret file, I don't have access. So it's not getting me anywhere. But the point is, there is a brief period of time between the time of check and the time of use. So if I was to somehow able to move from one to the other quickly, I could create that situation. Let me see if I've turned off this one from before, and I have. Good. Okay, Q will do it. All right. So the trick here is you make a shortcut. So this will create a symbolic link. And let's see if I have one left over from before. I do. So let's, if I try to create a new one, it's going to complain that it already exists. So what I have to do is use F. Okay, so I can force this. So now I've made a link. And if I do ls space -l, this flip points to secret. So if I try to use race to print flip, it'll tell me I don't have access to it. Now if I change flip to point all right, I'm confused. Oh, what? secret flip. All right. That should have done it. All right, I'm losing my mind here. LSL, flip secret. Let's see if I can remove it. It's owned by Noob. Remove flip. All right. No, it's still there. All right, what's going on here? Oh, it must still be running that process in the background. Yes, it has. Okay. So I thought I had prevented that somehow. There it is. This process is running. I need to kill this process. 26767. Okay, hold on a minute. Kill 26767. Okay, now if I do ls minus l, this thing is pointing to secret, and if I link it to public, there. Now it's pointing to public. This is what I wanted. So when it's pointing to public, I'm able to run it, race, flip, and see the public information. But if I change it to secret, now I'm not able to see in there. I don't have access. So all I have to do is flip back and forth quickly. And you can do that with this command. This will run a one-liner of bash. It will now change it to secret, change it to public, change it to secret, change it to public, and just do it as fast as it can. This is what was running in the background, confusing me earlier. I forgot to turn it off after testing it before class started. So if you run that, now it's, if I do ls minus l, flip points to public. If I just do ls minus l a few times, there, now flip points to secret. Flip is flipping back and forth many times per second between public and secret. And now if I just do race, flip, I see the public information, and then I didn't have access, then I saw the secret information. I just have a chance that when I run this command, it will check while it's pointing to the public, and then it will read it when it's pointing to the secret. I just wait for the random time. And this is how many privilege escalations work. There are a whole series of them, like the cow. There was one having to do with something to do with cow in the Linux kernel. And a lot of them where there's some temporary moment when you can escalate privileges. Anyway, so that's all I wanted to show you. A little fouled up, but that's the way it is. And that you can set that up and run it, and it's worth extra credit.